So memory management, I think it's a very important one while we are seeing to that, because while I'm recording this recording sessions and all, we used to say the memory is very important, and some of you have asked me to share this recorded file. I told you that it's not easy to that to share to the size of the file. So the memory, whatever the technology comes, the memory management will plays a vital role on having the files and all. So one of the important concept we have seen in the pointers, because while we are allocating the integer variables or any array variables, we have seen that the memory occupies will be very high. But while we are going for that memory management, we will effectively use the memory. So I think ma'am have covered about the introduction of pointers, array using pointer, and structure using pointer. Structure using pointer is not that it's similar to that of the topic we have covered in that, and functions using pointer. So we will see today we will see to that dynamic memory allocation. Okay, we will see to that dynamic memory allocation. Okay, so you just see to that what is dynamic memory allocation. I think this is one of the important part B question. I can say that a dynamic memory allocation in C, they may ask you to explain any one of the, any 2 or 3 of the dynamic memory functions. They may ask in part B, so it's one of the important part B question. Okay, there are 2 methods allocating the memory. We used to say it's a static memory allocation, dynamic memory allocation. From the name itself, we can say static is means it is fixed one. We cannot able to change it. But when you go with dynamic, it is nothing but dynamic. It is a changing one. It's clear. So we see to that this particular dynamic memory allocation definitely will comes under the category of dynamic memory allocation. So static memory allocation means the memory allocation is fixed. We used to say dynamic memory allocation, the memory allocation will change. Where it will be changing? That is the next question will be arised. When a variable is declared, okay, when a variable is declared, a compiler automatically allocate the memory. That is, we used to say static and dynamic. Okay, once I am declaring my variable, for example, integer na 4 bytes will be definitely will be allocated. Character na it is a 1 byte memory, it will be allocated. When you go with that float, 4 byte of memory. So while I am declaring itself, my compiler will allocate the memory for it. Okay, that compile time memory is called as a static memory allocation. You may take it as a hint. Static memory allocation means compile time. During compile time, the memory will be allocated. It is not be changed. It is a fixed one. That is static memory allocation. The best example, whenever I am declaring any variable in my program, that will be static memory allocation. Okay, so when you going to see to about that dynamic memory allocation, we will see that memory can be allocated for data variable after the program begins execution. We all know to that first we will compile and then we will execute. Compile will always do the process of, it will allocate the memory, it will check for the codes and all. So that will be that once I fixed my data variable, once I declared my data variable, automatically before my program executes will begins, the memory will be allocated. That is static memory allocation. And we used to say static memory allocation is nothing but it is a fixed memory allocation. That memory allocation will be done in the compile time. Okay. Now we move on to the dynamic memory allocation. Very simply, we can say that dynamic memory, it's a variable memory allocation. I told you, it's not a fixed memory allocation. It will keep on changing. So that mechanism, that is runtime memory allocation. So one of the very important point to, we can see that it will be compile time. Will be compile time. Okay, static memory will comes under the compile time memory allocation, and dynamic memory will comes under the runtime memory allocation. And this, from the name itself, we will say it is a fixed memory allocation and it is a dynamically changing. the memory allocation will be changing, because depending on my input, it will keep on changing. That will be runtime memory allocation. Okay, we used to say which will be the best, static or dynamic. From the name itself, we will say to that dynamic memory allocation will be very best, because it will be used the memory effectively. One best example I will see to that, while I'm declaring my array, what I will do, I will take my data type int and I will declare my array name A. And if it is a single dimension array, I am giving 100. Okay. What you can understand from this, the variable integer, it is declared under the name of array A, and we all know what is the maximum array limit, 100. I have given 100. Okay, that means I can use 100 inputs here. Okay, 100 means, for example, integer, if it is a 32-bit system, we all know integer, how many bytes will occupy? 4 bytes. So automatically 100 into 4, how many bytes will be given? 400 bytes. Okay. But for example, I am going to use only 10 inputs. In my runtime, I am going to give only 10 inputs. Okay. But in 10 inputs, how many inputs are wasted here? 90 inputs are get wasted. When you go with that 90 into 4, I have not used 360 bytes. I have used only 40 bytes. So you all think that it's a single variable. I'm saying that 360 bytes get changed. And even when you see many of our uploading, and when you see that in our uploading your answer sheets, we used to say this will be 40 MB will be your maximum memory size. Similarly, in assignment also we will fix it. Okay, so that we will fix the memory. Okay, you cannot able to exit, and you will see some of the you have seen how you have applied for some NEET examination or some or entrance, whatever may be. It asks you to upload your image. So at that time, it will show that your image size should not exceed 10 KB. So that kind of, while we are going with that, the memory is one of the important, and that's why this entire unit, we were focusing on the first part of the unit is about to the memory allocation. That's why we have seen the pointer. Pointer is also effectively used the memory and management. And while we see that, that is one of the important concepts. While we are learning about the C, some of them were very new to C, and while you are learning that, you will see the phase how we have started the C, while we are declaring the variable, and we will move on to the control statements, and then we move on to slowly the functions, while we can subdivide the program and we can write. And if I want to declare more variables in the same data type, we go with the array concept, and then we move on to the structure concept. If I want to declare the different variable, if I want to use the string, I have to go with the string handling functions. And now we have gone to the phase of memory management. That is nothing but dynamic memory allocation. Is clear? So here, yeah, some of them have put that memory allocation function. Yeah, very good, very good. Some of you have known that, but anyway, I told you that some of them were very new, while we have to start to that. Okay, so we will see what is static memory allocation. The process of allocating the memory space at compile time is known as static memory allocation. Static memory allocation is fixed. That's why they have given the example. Okay, array, integer is my data type, A is my array name, and 5 is my I'm giving. So that automatically what you have understand from that now, I cannot able to increase my memory size. So some of the disadvantage they have listed out in static memory. Size is not expandable. Once I gave 5, it is 5 only. In runtime, I cannot go and change. In compile time, I will during my programming code I can change, but runtime the size cannot be changed. And similarly, I cannot able to insert anything. It's not a easiest one, and it is a time consuming process, because we used to say for loop and we will put it all that array in A of 5, we will get the input. So insertion of that document thing is also very difficult, and deletion is also difficult. So when you go with static memory allocation, this has the following disadvantage. I cannot able to increase the size. I cannot able to insert, but it can be done. But again, the coding we have to done so many process, and deletion is also difficult to delete, because we all know that once array is declared, it will give the contiguous memory location. That is, continuous memory location will be given. So to that, you have to understand that size is not expandable, insertion is difficult, deletion is also difficult. Okay. I think this is about the disadvantage on the static memory allocation. Okay. Now we will move on to the dynamic memory allocation. So I told you that the dynamic memory allocation, allocating the memory space at runtime. Runtime, I can able to give my memory allocation. So that this memory allocation is not fixed. It is a change. That's why they have used the concept linked list. Okay, so linked list is nothing but we used to say this linked list is a concept collection of more than one nodes linked together. The similar way, what we say to that, we have we have some malloc, kelloc, some functions will be there. Depending on that, we will allocate the memory. So sometimes the memory will be allocated as a block of memory, and sometimes it will be allocated a single space of memory, whatever may be, depending on that node. Node is nothing but the data element. Okay, and similarly nothing but the live address, both will be linked. When you see that they're saying this is a node. What is node now? Node is nothing but data part as well as the address part. So both will be linked, and it will be go to the next data. So the linked list concept is also comes under the category of dynamic memory allocation. So it have a two link, that is nothing but the nodes need not to be stored continuously in the memory. That concept is not to be there in that dynamic memory allocation. But one thing you have to use to that. So depending on your number of elements, the data as well as address will be there, and the two field will be automatically linked, because that's very, very important one. So the two field will be linked. So they were saying that, so the whole part will be linked with the next data. And one more thing, the nodes need not be stored in the continuous memory location. Okay. So here, what is the advantage of this dynamic? Now, size is not fixed, and insertion is also easy. Deletion is also easy. So I can able to do all this kind of operation. What are the disadvantage in the static memory allocation? That will be overcome in the dynamic memory allocation. Yes, we all understand what is static and what is dynamic. I think you may easily correlate with this static and dynamic memory allocation. And again, once again, a small recall for the pointer. Don't forget this slide, because this will be one of the things. Asterisk will be give the value at the address operator. You just note it in your notebook. Already I have mentioned you. Ampersand is nothing but the address operator. Okay, and first one will give the value stored at particular address, and the next one gives the address of the variable. So asterisk is nothing but value at the address operator, and ampersand will give the address operator. So why I am telling this, keep on now, again, while I'm writing the code, you should not forget this. Okay, asterisk will give the value at the address. For example, this is my address. 1000 is my address. Okay, and 40. So this asterisk will gives the value at the address, and this ampersand gives the address of the variable. So that you have to understand. Okay. Now, please kindly note down this dynamic memory allocation. I told you that this will be one of the important part B question. Malloc, kelloc, size of, free, realloc. All this will be the dynamic memory allocation. Now, can anyone tell any one of this dynamic memory allocation have you studied earlier? Which memory allocation function you have studied earlier?
Size of.
Very good, very good. Size of, where you studied?
In basic, what size of integer,
Data type.
float, data types.
Not data type.
Size of
Very
data type.
precisely I'm asking. You won't learn in data type. Actually, data type length we will use to find out size of. But this particular size of where you learn. Yeah, actually very precisely when you go on, you have learned in C tokens. Basics only, that is that. But in data type, we have learned about what are the three data type: primary data type, derived data type, and basic data type. We have learned about that. But when you go to that, this size of, it is nothing but it will comes under the C tokens you have studied. Okay, in the special operator, Ranjit have mentioned. Okay, so you see to that, but there we studied about that. But here now we are going to learn about malloc, calloc, free realloc. So please kindly note down this. Dynamic memory allocations, malloc, calloc, free realloc. This dynamic memory allocation will be covered in the two header files. One is stdlib.h and another one is alloc.h. Okay, we all know the header file is very important in C. So all this keywords, while I want to access, I have to include my header files or else it's not possible. So kindly note down this. Have you all note down? Now we will see that one by one in detail. Is clear, ma? Have you all note down? Okay, malloc, calloc, size of, free realloc. This is one of the important part B. I am repeating same thing. Okay, now we will see to that. C is a structured language. We all know the rules are very fixed. And while we are saying about the array, we can change the size of an array. While we are saying, ma'am, while you see to that array is fixed, how I can change my array? While see to here, array length will be 9 because 0 to 8. Okay, and we all know it is start with the fixed index a of 0. This is the way we will access. A of 0 is 40. Okay, and while I'm declaring A of 8 is 89. Okay, situation where only 5 elements are needed to be entered in that. The 4 is nothing but wasting the array. I told you that I need only 5 into 4, 20 bytes of memory only I need. Remaining 4 into 4, 16 bytes of memory is getting wasted. And similarly, while see to the concept is nothing but I want to change the size of the array from 9 to 12. Whether it is possible, I want to include 3 more. That is also not possible. So we all told that size is not expandable. Deletion is also difficult. Insertion is also difficult. So to that, while we are going with same thing array concept, how we can go with the concept of using dynamic memory allocation. Okay. Now we are going to enter into the malloc. What is the full form? Memory allocation. That is malloc. Okay. Malloc, you just note down. It is nothing but it is dynamically allocate the memory. Please write down this syntax. This time we have asked one thing in 2 more. Write the syntax of for pointer. Okay, the similar way, sorry, not pointer, write the syntax of for switch case we have asked. So the similar way, the syntax are very important. You have to know that. So write down the syntax, then only it will easy for you to write. Is clear? Pointer, cast type, asterisk, malloc, because malloc is one of the keyword of C. Okay, byte size. Have you all noted down? Yes, have you all noted down the syntax? Okay. Now, example. Definitely, while I am declaring my malloc function, I have to use the pointer variable. That's why PTR is not okay. So PTR will always, you know that while I'm declaring int asterisk PTR, we will declare now that pointer variable is that PTR. PTR is not a keyword. Okay, so that PTR refers here, PTR cast type. We all know that in the data type, we used to put int, we used to put float and all, or short int, depending on that. So that is the cast type. We have to definitely declare malloc, okay, 100 into size of int. Because I told you the size of, we already known that while we have executed the program, how to find out the size of the variable depending on system to system. It will vary depending on whether you are a 32-bit system or 64-bit system, or it may be a lower end version of system. So size of that, so that's why 100 into size of, why they have internal. For example, the integer size is 4 bytes now, it will automatically allocate 400 bytes of memory. Okay, so here, ma'am, you have already told it is a runtime, we can change it and all. Then why you put 100 and all? I can enter that as a n. N is my input. For example, runtime, if I give n value as 5, 5 into 4, 20 bytes. Runtime, if I give n equal to 10, 10 into 4, 40 bytes. Runtime, for example, I have to give n equal to 50, 50 into 4, 200 bytes. So that n will change depending on my input, what I'm giving in my runtime. But here for the example, they have written 100 because we all know that maximum value we will give it in array will be 100. But one thing I can put it declare under the variable that 100 as a n. Now I can get the n through my keyboard, and that depending on my n value, my malloc function will dynamically allocate the memory in runtime, not in the compile time. Yes, yes, thank you. Okay, now you just see to that. I told you the pointer is nothing but it's a variable, pointer variable only. We all know that asterisk will always the one of the important operator to declare the pointer variable. So normally you know the difference between int pointer and normally int a and int asterisk pointer. So the pointer PTR is nothing but I'm declaring under the pointer variable. Okay, now I'm giving my n value as Fatma. What is my n value? 5. Okay, and enter the 5. My integer, how many integer, how size of int? For example, my integer having the size of 4 bytes. So how it will
20
allocate?
bytes.
Yeah, 20 bytes. It's a nothing but a large block of memory. 20 bytes of memory will be allocated to PTR, pointer variable. It's clear? Depending on the size of n. Size of n can be done. If space is insufficient, allocation fails and returns a null pointer. If my memory cannot able to allocate it, for example, if it exits or if the memory is not sufficient, definitely it will throw the message, the memory will not be allocated. Is clear? If it is a null pointer, when it will can able to allocate, for example, it have the sufficient space only, it will allocate. If so, if not so, it won't allocate any memory. Is clear? Okay, now I will explain you with one simple program, and I will execute this program in C compiler. Okay, one of you were asking the doubt, ma'am, my LMS C compiler is somewhat tough, and while I'm executing in my online GDP compiler is easy. You see to that GDP compiler, you are giving the input and you are executing. But when you go with the LMS compiler, we were giving the test case. That means you have to understand, according to my test case, your program should be validate that, and it has to be executed, and it has to verify with the result. So it will be somewhat tricky. And one thing you understand that the way it will be asked in your placement. Okay, and most of your GDP compiler have the practice, don't have a practice in any other compiler. Why? Because I'm insisting that point now. Our placement is also having with this GDP compiler. So always have this practice. That's why we were giving this practice in the GDP compiler, as well as we were insisting you to do it in LMS. Is all of you clear on this point, ma? Yes. So we always practice on that. Okay. Now I will explain you how using malloc the program is executed for that. Okay. We all know that. Why stdlib.h, ma? Why stdlib.h?
Standard library.
Why I am including this stdlib.h? Standard library is okay.
Header file.
For what purpose?
To allocate.
I want to use DMA functions. Definitely, I will use stdlib function, or else it will show that the error message that this particular header file has to be included. Then only this particular line will execute. Is clear or not? Otherwise, it will not be useful. Yeah, correct, ma. Okay, next, I told you that if I want to hold the address, definitely my pointer variable has to be included. So I am including int asterisk pointer. Okay, I need not to declare always PTR. PTR is my variable. I can declare simply P, simply A, simply B, whatever that. What are the conditions you have studied to learn in the identifier or variable name? The same procedure will be followed in the entire C. To declare the variable name, it should always start with the alphabets. It should not start with, sorry, it should not start with alphabets or special characters. It always start with, sorry, I told that it should always start with the alphabets. It should not start with numbers, and it should not start with the special characters, that and all things. And the alphabets, while I'm declaring, my lowercase and uppercase will be always different. Okay. Now, n comma I. Why n comma I? N is nothing but the number of array. For example, I told you runtime, I can change my n value. I can change my n equal to 5, n equal to 10, n equal to 20. That's why I have used n. But here I declared n equal to 5. I will do it in the compiler. Okay, I will change the n value often, and I will tell you how it is allocating the memory. Okay, but this program, they fixed n equal to 5. Okay, now for example, n equal to 5 now. What will be the memory size, ma? What will be the memory size according to my system? I already executed the size of the integer for my system.
64 bit.
Yeah, okay, 64, okay. But what is the size of the integer?
20.
20, yeah, Navin, thank you all, some of you. Because
Five
n I
into
have
4,
put 5 into 4, 20 bytes will be allocated. 20 bytes will be allocated. I told you, if memory is not sufficient, definitely it will declare, it will return the null variable to pointer. So at that time, if it is returning the null variable, automatically what if pointer equal to null, it will say to that memory not allocated. My memory is insufficient. So definitely we will exit. Okay, and automatically it will exit from the program. Okay, now else, we all know what is this condition I'm using. If I'm using, definitely if else. Okay, if else, you may ask, ma'am, definitely I have to include that. Actually, we will see various cases using this malloc. If pointer equal to null, at that cases only memory not allocated. If I'm not checking that, if my memory is sufficient, I need not to check this condition. But anyway, all malloc, calloc function, we used to check whether memory is sufficient or not. Okay, else. Okay, else memory is successfully, automatically that if it is not returning the null variable to the pointer, then automatically what the message it will, we will put it now, memory is successfully allocated using malloc. Okay, now I have used for loop. Why for loop, ma? We all know that I want to give my input through the keyboard. Definitely for using for loop, I will get my input. So for I equal to 0, I less than n, I plus plus. Okay, now pointer of, we all know that I can, here you tell me that what is my variable value. Actually, here I will use scanf. Scanf now how I will tell me the syntax. If I am getting my input, tell me any one of you. Any one of you, tell me. Put it that syntax in chat box. If I am getting through scanf statement, what is my syntax? I want to get my array variable.
Percentage D comma.
Yeah, percentage D is mandatory. Yeah, okay,
Comma. Array I.
PTR of, that is ampersand is PTR of I. Very good, very good. I have to use it. But here what they put, PTR of I equal to I plus 1. That means what, ma'am? While we are seeing to that, what is my first I value? What is
0.
my first? 0. So I equal to 0 means PTR of 0. PTR of 0 equal to what is the value, ma?
1.
0.
1.
Okay. Then I equal to 1. Next case?
2.
2. Okay. Then next case?
3.
3.
3. Okay. Next case 3. I equal to 2, 3. Okay. The next case?
4.
4.
PTR 3 equal
3
to
only.
4.
Sorry. This is 3 only. Okay. The next case?
PTR 4
4.
equals to 5.
5. PTR equal to that 4. I
4.
equal to 4.
Equal to 5.
5. The next one?
PTR
No,
5
ma'am.
equals to 6.
What is
No,
the
ma'am,
condition I have written?
No, ma'am.
No,
Less
ma'am.
than n.
No,
Less
it
than
won't
n.
come. I less than n. What is the n value we gave in the program?
5.
5 only. So what is the value will be stored in a block of memory? We told na 20 bytes. 1, 2, 3, 4, 5. All are my data. This data will be stored in the 20 bytes of memory. Yes, you all clear? 20 bytes of memory will be allocated. So when you see to that 1, 2, 3, 4, 5. This is whatever. This now it will show that now I am printing my array elements. The elements of the array are, I am printing PTR of 0 is I equal to 0, I equal to 1, I equal to 2, I equal to 3, I equal to 4. It will print all the values. So PT. So if I want to get it through my keyboard, I will put ampersand and I will get it. I will give any input. Okay. Shall we execute this program? Shall we
Okay,
execute?
ma'am.
Ah,
Yes,
Okay,
ma'am.
ma'am.
we will see to various cases and we will execute. Okay. And one more thing, your pointer PPT is open. Now you can access in LMS. Yes. After completing each topic, we will put to your, we will upload your thing. So now you can able to access. Okay. Okay. So for this particular program, n equal to 5, I gave. So just see n equal to 5. You all see this all. I will remove it. Then the program will easy to understand that. Get the number of elements. So to allocate the dynamic memory, we use that syntax PTR, cast type asterisk, malloc, then the size of bytes. That is n value. Depending on that. If memory is not allocated, then automatically if PTR is null, then automatically it will throw a memory is not allocated, or else if it is not so that, then memory will be allocated successfully. Okay. So that's why we gave the statement, the memory is allocated successfully, else then I'm getting my, what is the array element according to the statement? I equal to 0, I equal to 1, I equal to 2, I equal to 3, I equal to 4. So it is printing 1, 2, 3, 4, 5 value. Okay, now I will run this program. I'm taking classes. You people are asking about some of the doubts. Okay. Just ask subject related doubt. Okay. Law department and all, I don't know. Okay. Why enter number of elements? Because I gave n equal to 5. Now it is showing that memory successfully allocated using malloc. Then in printing 1, 2, 3, 4, 5. Okay. Now I don't want to give that n value 5. Okay. Now what I will give ma? Scanf. I will give percentage D. Sorry.
Ma'am, capital
Cap-
letters.
Scanner
Yeah, thank you,
capital.
thank you, thank you. Scanf. Percentage D,
Comma.
comma, n value. Okay,
MS.
okay, that here now I'm saying that my n value is
Ampersand.
keep on
Amazon,
changing.
ma'am.
Ampersand.
Sorry, ampersand n. You are all very clear. So I'm saying that my n value or keep on changing. So now I will take my n is 3. Okay, actually I have to enter my n value. Then only it will print the other values, because I didn't give any statement. Print of enter the number of elements. Actually, it has to be come before. Okay. Okay, anyway, we will execute. Okay, enter the number of elements. If I run, enter the number. I'm giving 3. Okay, so memory is successfully allocated. So it is printing how many values, ma?
3.
3 values. 1, 2, 3. You just see to that. 1, 2, 3. If I give the space or /t, then automatically, I think here the space will come. So automatically it will print 3 values. 1, 2, 3. Is clear, ma? Okay. Now I told you one of the thing, instead of this, I have to give my value through keyboard. So definitely I have to use scanf. So I will delete that. And what is that? I will put PTR I. Okay. Now I will execute my value. Enter the number of elements. So I'm giving 5. Okay. Now memory is successfully allocated using malloc. Okay. Now 10, 20, 30, 40, 50. So if I enter, I can able to enter only 5 values. So the elements of the memory are 10, 20, 30, 40, 50. Is all of you clear on this point? So you do that. First cases, I have calculated, I have given one expression. Through that, I gave my value of getting 1, 2, 3, 4, 5. Or else I will use the scanf statement to get my value. And I'm just printing the value. I'm not doing any other process. So what you have understand now, runtime. During runtime only, it is allocating the memory. It is not allocating the memory in the compile time. Why? Because due to this particular statement. You all know PTR equal to. Actually, I told you this statement is optional only. If memory is insufficient only, at that time, check once for excess input, ma'am. Okay, we'll do it for excess input. So actually, I can give around 20 is maximum case. Okay, then you all see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So you see to that, it's a 20. Maximum is 100. Is clear, ma'am? So depending on my n value, it will keep on changing. Yes? Is all of you clear on this point? Have you understand this malloc function? Yes, thank you all. Thank you all. No, ma'am. Input more than memory. Actually, you all understand that this particular function, you all understand. First case, I gave n equal to 5. So 5 into 4, 20 bytes. Next case, I gave n equal to 20. 20 into 4, 80 bytes of memory is allocated. So input is not more than the memory. Is clear on this point? Yes, will it show error, ma'am? What, Sanjay, I can't get it. What, when will it show error? I can't get it your point, no? You may unmute and ask your doubt. If, ma'am, if exceeds the range of declared bytes, you get it one point. I'll go to the program. Here, what is the condition I have given? If we exceed the range of the declared bytes, definitely you all understand. Here I am declaring int only. So depending on int, and we gave I less than n, we have given all the conditions. Then how it will be exceeds the range? When it comes under the, we cannot able to, for example, I'm giving 4, 3 input. Okay, memory successfully. First input I gave 1, and second input what I did 20, 8, 9. I'm giving big value. Okay, for example, it is a long integer. Okay, maybe 56.7. Have you seen? It will throw the error message. If I'm not properly giving my input, definitely it will show the garbage value. So see, the last value, it is truncating. 56.788, whatever maybe, I will delete all my your floating values, decimal point values and all, and it is. And it is not, I'm not giving an integer value. When null will be executed, ma'am, in which case? If memory is not insufficient. But this case, it won't arise, because here, without this statement also, my program will execute. That's why I told you. Without this program statement also, my program will execute it. For example, I'm deleting this point. Okay. Now I'm executing this program. Okay, I'm giving 3. Then 1, 2. I need not to check. But why I am checking that null and all, na? Why I am checking that null and all, na? Because to understand to that, we always saying that, na, if pointer is returning the null variable, at that time, if memory is insufficient, at that time only this case will be used. Is clear? Okay. Then while going with Kellogg, I thought this will be helpful. Yes. Okay. Malloc is get over. Yeah. Now I will move on to Kellogg. Kellogg is nothing but contiguous allocation. Okay. Then what is the difference between malloc and Kellogg? We are saying that now malloc is nothing but memory allocation. We have studied the full form of malloc, memory allocation. Kellogg, contiguous memory allocation. Allocate the specified number of blocks. Okay, we will see. I will explain with you the thing. PTR. You just take down the syntax for Kellogg, cast type, asterisk, and the keyword for the Kellogg is Kellogg, n comma element size. It's not a block of memory. It is nothing but a number of blocks. There we have allocated a single block of memory. Okay, but it is nothing but a number of blocks depending on the data type. Okay, I will show you the show you the diagram. You just take down the syntax first. You just take down the syntax more. Have you taken? Yeah, thank you, ma. Okay, cast type. I told you the cast type. If I'm declaring my float, I have to definitely put float asterisk. Kellogg 25. I told you the n will be. We have explained with one of the example. My n value will keep on changing. Okay, because runtime I can change. Element size of float. So this system allocates contiguous space in memory for 25 elements. Okay, we will see with the size of float. Float 4 bytes now. Have you seen? It is not a single block of memory. It is nothing but a number of blocks of memory. Okay, so you see to that here 20 bytes. 4, 4, 4, 4, 4. 5 blocks of 4 bytes, each is dynamically allocated to pointer. That is one of the best difference between the Kellogg and Malloc. Malloc will allocate the block of memory and Kellogg will allocate the number of block of memory depending on the cast type. You want to put the diagram, you just put it a simple diagram to understand. The next PPT is about the difference between the malloc and Kellogg. And similarly, another important, if space is insufficient, allocation fails and returns a null pointer. That will be the same concept. If memory space is adequate only, we can able to allocate the memory, or else it will return the null pointer. Is clear? Okay. And this is one of the important difference, or 2 mark. We can say that what is the difference between malloc and Kellogg. So malloc, it is a single block it will allocate. But when you go with that, I think I will zoom it and show you. Yeah, I think it will be well good. It will allocate multiple block of requested memory. Okay, so 20 bytes now, 20 bytes is single block, and here it will depending on the float, 4 byte, 4 byte, 4 byte, 4 byte, 20 bytes of memory. Okay. Yeah, one of the thing you have asked, malloc doesn't initialize the allocated memory. It contains garbage values. While we are seeing that, while I'm declaring that it will returning the garbage value, but Kellogg initialized and allocated the memory to 0. Okay, if it is not that, it will returns the 0 value. And one more thing, typecast. Typecast must be done since this function written, because both the category, okay, PTR is nothing but a pointer variable, int asterisk PTR. But both the cases, that will be very, very important. 5 into size of it, int, and this is also 5 into 5 comma size, and mainly the difference is malloc and Kellogg will be the important difference. Yes, have you understand? Have you understand?
Yes, ma'am.
Yes, okay. I think we will change it and we will do it for Kellogg, the program we done earlier. Okay, same program, but instead of malloc, what I have to put? Kellogg. That is the only difference. What is the program you have done? The same program. So I think I will change the word malloc into Kellogg, and we will see how it is working in our online GDP compile. So run. Okay, actually it is not n asterisk, n comma. That is the one another change. N comma. Okay. Enter the number of elements. Okay, so 4 memory is successfully allocated using Kellogg. Okay, it is saying that runtime we cannot able to execute. So same thing, I can give my input through my keyboard, and this is the only change what malloc and Kellogg is doing. Malloc is doing the single block of memory and Kellogg is doing the multiple block of memory. Is clear? And both will return the null variable if the memory is insufficient. Okay, I'm giving 3. Okay, so you see to that here it is returning the garbage value only, but when you see that the memory is, it is truncating the value and it will return the integer value. There it will return the garbage value, and similar to that, this is also a garbage value. Okay, but when you execute the same function, it will return the 0 value in the turbo C. But we used to say all are the garbage value, but while we are executed in the Kellogg, it will return the negative value. It is not related to the integer value. It is written some other value. Okay, signed integer value it have written. But while we see to that, the same thing, it has to be always. So instead of int, I'm using float. You all know that this particular function will not be executed for integer variable. We always doing integer. If I want to do it for float, wherever I want to change my code, kindly guide me wherever I have to change. I want to do the Kellogg function for float variable. Where I have to change. Students? A meeting. Are you there in the meeting?
Yes, ma'am.
Tell me. I want to do it for float type. So where I have to change?
In int plus you want to put float.
This pointer variable comes under what type?
Float.
Float, definitely float. Okay, and n comma I, that will be definitely integer. Okay, here what I have to put?
Float.
Float.
Float. And here what I have to put?
Float.
Float.
Float. Okay.
Their percentage of.
Yeah, very good, very good. Instead of percentage D, what I have to put?
F.
Percentage.
Percentage F. Okay. And here?
In 9 line, ma'am. 9.
9th line.
9th n D integer only.
9th line, ma'am.
That is integer only.
Integer only.
N equal to 5, n equal to 10. It is nothing but size of the array. That will be give only in integer. Okay, that won't get changed. And while we are seeing that the one of the condition we have seen that index value should be always in integer. Okay, okay. Next point. Next where I have to change. Enough. Next where I have to change, man. Please kindly tell me. Is it enough or where I have to change? Getting input, I have. Yeah, tell me. 28th line. Yeah, very good, very good. And here also I have to change. Okay, I'm putting 0.2f. So it will do 2 decimal thing. Okay, now I'm doing a run. So 5. Okay. Then 14.56, 12.32, or simply 14, and 67.89 and 98.67 and all I'm putting. Okay, I'm just executing. You just see 14.56, 12.32. For even though I give it as an integer, it is display as a float one. 14.00, 67.89 and 98.67. Or you all get it that ma? Yeah.
Yes, ma'am.
So
If we submit 0, it will take as element or not?
Where ma?
In 5 elements, if we substitute 0, one element as one element, it will take or not output.
Oh, your question is instead of this, enter the number of element is 0.
No, ma'am.
Ah.
In 5 elements, we are taking one element as 0. It will take as output.
Yeah,
0.
definitely it will take. Definitely it will take. 0
Okay.
is also the value, no? Our example 3 I am giving. One is 1 and another one is 23.44 and another one is 0. Na? Definitely it will take.
Okay, ma'am.
Okay. If I am giving n equal to 0, it won't execute anything. It won't accept any input. Because my size of the array element is 0. Na? 0 into 4 what ma? 0 bytes. So it won't get any accept any input. It just exit from the program. Is clear? All of you clear?
Yes, ma'am.
Okay. So I think today we have seen about this malloc and kelloc. Yeah. The another function is nothing but free. Okay. I think I will teach you in the next class. And one more function is realloc. Okay. Free and realloc will be there. So you kindly we will see to this free and